The main focus for the crew on board the International Space Station this fall is on the station's top priority: groundbreaking scientific research that can't be done anywhere else, science that helps the people of Earth today and advances the technology needed to support space exploration beyond Earth tomorrow. This crew brings a range of experience to the task, starting with a commander who is finishing up his third long-duration spaceflight with special attention to experiments that could change lives on the ground.
We're working with experience for AIDS, for hepatitis, and for cancer. And if we help humans for one of these directions, I hope we're done with everything, with each dollar, with each ruble on space station program.
Two of the flight engineers, now more than 100 days into their first long mission, are working to find out how the environment of low Earth orbit impacts human bodies.
Probably one of the most important things, at least from the crew member's perspective, is crew health. And so we need to look at all of the things that radiation and lack of gravity do to us and make sure that we can mitigate all the negative effects as much as possible.
Some of that research into ways to protect people from the effects of spaceflight is paying off for people on Earth. For instance, the use of a portable ultrasound machine to map changes to the spine over the course of a spaceflight has applications for using a similar machine in other remote locations.
And developing protocols and softwares to improve the imaging on these machines could mean that soon after we complete our experiments, the technology that we import on the ground could help people all over the world to have access to better diagnosis on their spine.
A once and future space station commander, who is also a medical doctor, has 2 long-duration flights to his credit already, and so he has some insight into areas that need special attention, such as the impact to the vision of some crew members.
The intracranial pressure changes are very serious problems that we need to address. Intraocular pressure changes. So we need to develop some procedures, measures, how we can protect crewmates from that. So this helps not only crewmates, but people on Earth as well.
This crew includes a biochemist whose research has focused on how space travelers lose bone and muscle mass and suffer impacts to the respiratory and other systems of the body over time.
We will start a new experiment to improve the countermeasures system. It's more of a physical exercise experiment. And we also pay a lot of attention to the vestibular experiments as well.
And the crew includes an aerospace engineer who brings fresh eyes to the science of the station on his first trip to orbit.
We have this bone loss, we have the muscle mass loss, we get taller, so all of those effects, we want to try and understand really what's happening and how can we mitigate some of those effects if they're negative. And so yeah, just being there, we are an experiment in work.
In the areas of human life sciences, as well as physics and physical sciences and technology development, plus Earth observation and education, the station's partner nations are pushing the limits of science as they get smarter about what will be needed to support future explorers on missions away from Earth that will last for years. On this flight, the crew will experience something that hasn't happened in years. They'll be part of a 9-person crew on orbit. That happens in early November, when another Soyuz spacecraft arrives. Soyuz Commander Michael Turin, NASA's Rick Mastracchio, and Japan's Koichi Wakata start their tour of duty by delivering an Olympic torch, part of the torch relay to the site of the Winter Olympics in Sochi, Russia, in February of 2014.
During this short period of time of direct handover that will last for 4 days, Oleg Kotov and I will perform an EVA, one of the tasks of which is to take the Olympic torch to space. We will take a picture with it, with the space station in the background, with the Earth in the background. And we will try to make sure that we see Russia and maybe Sochi, where the Olympic Games will take place.
They'll also retrieve a space exposure experiment and perform maintenance on other payloads on the exterior of the Russian segment of the station before bringing the torch back inside. 2 days later, Yurchikhin, Parmitano, and Nyberg depart the station with the Olympic torch in hand. Their departure marks the start of Expedition 38 and Kotov's second tour of duty as station commander. He and Ryazanski plan to do at least one more spacewalk in December to install 2 cameras outside the Zvezda module for an optical telescope system, exchange some experiment hardware, and remove and jettison 2 communications antennae from the Poisk module. After that, Expedition 38 figures to be the center of a busy space traffic pattern. The first operational flight of the American commercial cargo ship Cygnus is targeted to arrive at the station in mid-December and stay for a month. Shortly after it departs, the next Dragon cargo craft is due to take the docking port on the Harmony module for a month, and while the crew works on its shipment of supplies, they'll also receive another Russian Progress freighter. Kotov and his Soyuz crewmates leave the station in mid-March to come home to Earth, after nearly 6 full months in space pursuing the advancement of scientific knowledge, learning how to take care of human explorers in space, and learning so much more than that.
We're learning about the world in which we live. We're learning about the machines that it takes to get us there and how those systems operate and how often they need to be repaired and what works and what hasn't worked. And so all of those are such a critical part of taking that next step and going beyond low Earth orbit and continuing human exploration.